All right, let's jump right into this explainer. Welcome to what is, quite literally, a colossal scientific detective story. Today, we're going to unravel a crazy mystery about the absolute largest creatures to ever grace planet Earth. It's a story packed with giant bones, hidden desert fossils, and a really cool look at how the scientific method actually works to separate those flashy clickbait headlines from reality. So buckle up, because we're about to pack millions of years of evolution into one fast-paced journey.
I mean, since we were kids, right, we've all been taught this one undisputed fact about the natural world. The blue whale is the absolute largest and heaviest animal to have ever existed. Period. End of story. Bigger than the biggest dinosaurs, bigger than anything else in the oceans. But what if I told you that a recent wild discovery out of a harsh desert actually threatened to completely rewrite the record books? It really makes you ask, is the blue whale actually the heavyweight champion of the world?
Section 1. The undisputed heavyweight champion.
Okay, before we meet the challenger that completely shook up the scientific community, let's just ground ourselves for a second with our current reigning champ, the modern blue whale. Just to put into perspective what an absolute biological marvel this creature is, think about this number, up to 250 tons. While the max recorded weight for a blue whale on a scale is an astounding 190 tons, scientists estimate that the really big ones out there could easily push 250 tons or more. Guys, we are talking about a living, breathing animal that weighs as much as an entire fleet of commercial passenger jets. It's almost hard to wrap your head around.
And when you picture the sheer length, stretching up to 33.6 meters, or roughly 110 feet long, that means the blue whale outstretches even the mighty Argentinosaurus, one of the largest dinosaurs ever found. For decades, it just seemed absolutely biologically impossible that Earth could have ever supported an animal packing more mass than this ocean giant.
Section 2. Enter the colossal challenger.
But science? It's never truly settled. In 2023, a massive disruption hit the paleontological world. Headlines were flying everywhere declaring that a new heavyweight champ might be in town, threatening to dethrone the blue whale for good. And the wildest part? The scene of this groundbreaking discovery wasn't the deep ocean. It was actually the harsh, dry Peruvian desert. Hidden right there beneath the sand, scientists unearthed the fossilized vertebrae and ribs of a 39-million-year-old extinct marine mammal. These bones were ancient, they were massive, and they were about to challenge literally everything we thought we knew about animal gigantism.
So, meet the challenger, Prehistoric colossus. Sounds like a movie monster, right? This was an ancient whale belonging to a group of early, now extinct cetaceans known as basilosaurids. Measuring in at a staggering 66 feet in length, this creature was swimming the seas nearly 40 million years ago. But honestly, it wasn't the length of Prehistoric that made all those headlines. It was the mind-boggling density of its skeleton.
Get this, the fossilized skeleton of Prehistoric alone was estimated to weigh somewhere between 5 and 7 metric tons. To put that into perspective, that is 2 to 3 times heavier than the skeleton of a modern 25-meter-long blue whale. These bones were just incredibly thick and heavy, which, understandably, led scientists to make a totally shocking initial calculation about the animal's total body mass.
So, when researchers took that massively heavy 7-ton skeleton and mathematically scaled it up, they estimated that Prehistoric could have weighed anywhere from 85 to an unbelievable 340 metric tons. If that was accurate, this ancient oddball would completely shatter the blue whale's 250-ton record, officially crowning it the heaviest animal ever known.
Now you might be wondering, why on earth did it have bones that heavy in the first place? Well, researchers explained that Prehistoric likely lived a very coastal, shallow diving lifestyle, kind of similar to a modern manatee. Deep diving whales actually need lighter skeletons so they can surface easily. But Prehistoric, it needed massive, dense bones to act as a natural ballast, basically allowing it to hover in shallow water by balancing out the upward buoyancy of its massive air-filled lungs.
Section 3. Trimming down a giant.
It's a super fascinating theory, and honestly, a spectacular headline. But right here is where our explainer shifts from a cool fossil hunt into a real masterclass on the scientific method. Because in science, extraordinary claims require extraordinary scrutiny. You really have to stop and ask, how do you actually weigh a 39-million-year-old fossil? We didn't have the whole whale. We only had a few fossilized vertebrae and ribs. Trying to estimate the total body mass of a creature without knowing exactly how its soft tissue, fat, and muscle were distributed, that's incredibly difficult. And as it turns out, just scaling up a blue whale's blubber onto the ultra-dense bones of Prehistoric led to some pretty serious overestimations.
Just look at how this estimate evolved across peer-reviewed studies. When the news broke in 2023, the maximum estimate was that massive 340 tons. But fast forward to 2024, researchers used new scaling methods and downgraded that to between 60 and 113 tons. Then, in 2025, a study in Paleontologia Electronica further downsized Prehistoric to just 35 to 40 tons. It's like the incredible shrinking whale.
So boom, the mystery is solved and the crown goes right back to the blue whale. Prehistoric colossus was undeniably a weird, heavy-boned animal for sure, but its total body weight falls well within the range of modern whales and is way, way smaller than the largest blue whales. And hey, this wasn't a failure of science at all. It's actually a beautiful example of science doing exactly what it's supposed to do, reviewing the evidence, testing the theories, and self-correcting.
Section 4. The Real Gigantism Timeline. Which brings us to a whole new, really fascinating question. If ancient whales from 39 million years ago weren't actually the size of modern giants, when exactly did they get so astonishingly big? Let's track this over a 36 million year evolutionary timeline. Believe it or not, for the vast majority of their existence, baleen whales were actually pretty normal sized. They didn't hit their massive evolutionary growth spurt until relatively recently, only about 4.5 million years ago. And we know this because the fossil record suddenly just explodes with evidence of immense ocean giants right around that specific era.
And a really crucial piece of evidence for this timeline is the famous Matera fossil. Found in 2006 near an Italian lake, this absolutely stunning 26-meter blue whale skeleton dates back 1.5 million years. It is the largest whale fossil ever described, and it's definitive proof that extreme gigantism was firmly established in the oceans long before modern humans were even a thought.
Section 5. Why whales grew massive. Okay, so we've nailed down the when, starting about 4.5 million years ago, but that still leaves the biggest piece of the puzzle. Why? What crazy forces of nature pushed these animals to grow from the size of minivans to the size of multiple school buses in what is, evolutionarily speaking, the blink of an eye? Seriously, ponder this for a second. What happened 4.5 million years ago to create ocean giants? It wasn't just a slow, random mutation. It was a dramatic response to a massive shift in the Earth's environment, a catalyst so powerful it literally stretched the biological limits of marine mammals.
For a long time, scientists throw around a bunch of different theories. Was it Cope's rule, the general tendency for animals to just get bigger over time? Or maybe a defense mechanism to escape titanic megapredators like the megalodon? Actually, scratch that last one, because researchers found that megapredators were already dying out right when whales started getting huge. No, the real answer lies in that first point, a massive global climate shift toward an ice age that completely rewired the ocean's food supply.
So here's the absolute game changer. It was a brilliant chain reaction. 4.5 million years ago, glaciers started forming in the northern hemisphere. During the warmer months, all that nutrient-rich meltwater poured directly into the oceans. At the same time, shifting wind patterns caused deep coastal upwelling. All of this combined to create massive, seasonal blooms of tiny sea creatures. To survive this new world, whales literally had to grow enormous so they could store enough fat to efficiently migrate thousands of miles between these scattered, giant, all-you-can-eat buffets.
Section 6. The Future of Ocean Giants.
And that brings us to today, and a pretty sobering realization about the future of our heavyweight champions. Understanding this evolutionary past isn't just about solving cool fossil mysteries, it gives us a vital and honestly alarming window into their survival right now. Because whales ballooned in size in response to ancient climate change, their massive bodies are perfectly tuned to a very specific ecological rhythm of ocean upwelling and seasonal food blooms. But today, rapid, human-driven climate shifts threaten to disrupt those exact wind patterns and nutrient cycles. The very climate mechanisms that gave birth to ocean giants, they might now be their absolute biggest vulnerability.
I want to leave you with this provocative quote from cetacean researcher Annalisa Berta when she was reflecting on this massive evolutionary history. She asks, will they adapt fast enough? It took millions of years for them to reach large size. Can they shrink in 100 years? It's a heavy, profound question that really challenges us to think about how our rapidly changing world is going to write the next chapter for the heaviest animals on Earth. Thanks so much for joining this explainer.